So now it's time to kick off the pitch competition. Hope you're all ready for this. We are excited to hear from 20 outstanding startups, selected from over 350 global applicants, bringing bold ideas in health tech, meditech, and age tech. In the coming pitch presentation, we'll hear more exciting ideas and innovation, and we believe these startups can make a real difference and help solve global issues for a better future. So, but first, let me introduce our panel of judges. First of all, let me introduce Chief Operating Officer of Life Biosciences, Mr. Michael Ringel. And Managing Partner of Seven Wire Ventures, Mr. Roberto Gaba. Chief Medical Officer of Philips, Dr. Carla Gola-Perron. Chief Executive Officer of PHC Holdings Corporation, Ms. Kyoko Deguchi. Founder, author, the healthcare blog, Mr. Matthew Holt. And managing partner and founder, Part-Time Partners, and Ms. Abby Miller-Levy is joining us online. We are such an honor to have you all, and thank you very much for joining us today. So now, let's move on to the pitch competition. Kicking things off, our first pitch comes from Fathom X Pte Limited from Singapore. So the stage is yours.
Good afternoon, everybody. My name is Stephen Lim from Fathom X. I'm here to talk to you about using technology to empower women for better health. Okay. Now, what's the clinical issue? What is the number one killer or cancer for women today? Breast cancer. We are talking about 685,000 women dying because of breast cancer. And we know if you discover breast cancer early at stage 1, survival rate is more than 90%. However, if you let it degrade all the way to stage 4, the survival rate can drop all the way to 20. Now, the idea is to discover breast cancer early. Now, we are talking about a big market with 1.25 billion women around the world that should benefit from technology we can develop. However, mammography today reaches a great part of the Western world, the developed world, whereby in Europe and US, you are screening 80 to 90%, but not so much in Asia Pacific. In Japan, less than half of the women that's supposed to go for screening are going for screening. Why is that so? There's a serious shortage of radiologists. On the average of 100,000 women, you're talking about 10 in the United States. In Japan, 7. If you go down to China, 0.5. Serious shortage. What are we talking about in this clinical solution? We are trying to find cancer cells that appear as white in this black and white mammography image. It makes it very challenging for the radiologists. If you look at the third image on the right, that's a mass. You see a congregation of white in the middle. But what our AI is able to do is to highlight where the cancers are with the probability score, whether it's a mass or early classification. Makes it easy for the radiologist, or if you look at the image on the left, what you are seeing is exactly the same image, except we bound it up in a bounding box telling you the probability score as well. Or the one on the other side, which will tell you the maximum classification. Now, all this is shown to improve the efficiency and accuracy of radiologists with what they traditionally see in the black and white image and with the colored, coded, and bounding box. Now, we are basically not replacing radiologists. We are saying, let the AI run the first round, okay? And the radiologist or breast surgeon screen it, and then allow the AI to help you write a report, increase efficiency, accuracy, and reduce your healthcare costs. We have done various validation done around the world, your typical reducing false positive and false negative against state-of-the-art, which are radiologists. We have shown a double-digit improvement. We have also done a multi-center study in 8 different regions, top universities and hospitals in each of these regions, and with a high level of accuracy in AUC, above 0.9 on average. And we're talking about state-of-the-art at about 0.87, okay? And one thing to look at, we are actually pretty good at dense breast, which is a major problem around the world for breast, across all countries. And the data that were given to us, 87% of them comes from breast density category C and D, where we perform very well with a 0.9 AUC and above. If we make a comparison against other competitors we have in Europe, they are doing the same study in Japan with only AUC at 0.71, marked difference. Possibly because their AI was trained in fatty breast, okay? Fatty breast looks like the one on the left, don't see a lot of white. The one on the right, the dense breast, you have the muscles appearing as white. So it's difficult to find the cancer that appears white on white again. We have also done study to show health economics that we are able to reduce in terms of reading time. What's the benefit to the hospital? Reducing false positive and reducing false negative. We have done various regulatory approval. In the last 3 years of our commercialization, we got 7 regulatory approval in Asia. We are now testing in more than 50 hospitals in 11 countries in Asia, and we are expanding that ground and covering the top KOLs first so that there will be greater adoption down the road to show that we did not copy the logos. We actually meet these people in Japan, major institutions like Osaka, Keio University, TMDU, and so on, in Thailand, Malaysia, Indonesia, Philippines, Taiwan, Hong Kong, India, Brunei, China, and so on. We are now being integrated into 2 different countries, Singapore and Brunei, for national screening program, and we started receiving revenue this year from 2 countries going to 3 by next month, and we expect 7 by the end of the year. This is the founding team with a breast surgeon, with an IT expert, as both of them having their professional tenure in National University of Singapore, and myself, I've been running businesses in Asia for the last 30 years. Thank you very much for your time. I think my time is up.
Thank you very much. So now let's open the floor to our judges for the question. Would you please start?
Hi, thanks. Quick question. You said you have regulatory approval and already selling in 3 countries. Are you aiming for the insurance? Are you aiming for an insured market, or are you aiming for out-of-pocket market? Which is it?
Okay. In Asia, the reimbursement isn't so forthcoming like in Japan, in US. In US, we have a CPT code for mammography at $39, okay? But not so much in Asia. So Asia, the adoption rate is a little low. There's not a lot of national screening program as well in some countries. Like their screening program in Thailand, but they don't cover breast cancer. So you are still doing a physical examination. You tend to miss your early classification and so on. So at various stages. Ideally speaking, we want to be into the insurance program. Ideally speaking, we want to be in the national screening program. But we have to work at different level in different countries. So like I mentioned, in Singapore and Brunei, we are adopting into the national screening program. We hope to be able to use that as a springboard to get into other Asian countries as well.
All right, thanks.
Thanks. Yes.
Who are your main competitors? What are the strengths they have over you? And how will you differentiate to beat them?
Oh, okay. Today, I have, actually, we started because we participated in the US White House competition that gave us 640,000 images to train our AI. Most of my competitors globally, the top, all came from the top 10 in their competition, majority. So we have 1 competitor in Asia mainly. Outside of Asia, a few in US and Europe. We would like to think, based on data that we have seen, we will do much better than them in dense breast, even in Europe, okay? But we are good in fatty breast as well because that's where we first train our AI. In Asia, the only other competitor we are quite fortunate to be able to kick them out of some hospitals in places that we get revenue. So we feel that we're pretty confident of what we are doing. And the other thing is I find this, again, is an investor question, right? People ask you, since you're doing breast, why don't you do lungs and chest and everything else, So I say our decision is we will not go into that channel to be a jack of all trades, okay? Because in the actual application, you will find that it's impossible for you to keep a KOL relationship with 10 different departments. We want to focus on breast and radiologists, but we'll go deep so that in the breast area, we have multiple modalities. So we actually have a pipeline of products, not just mammography. And once we go deep into that, we don't fish a fish with one hook. We fish a big fish with many hooks. That's how you catch a tuna, right? So that's what you do. So with many hooks, you try to catch the same fish, and we develop many programs within the breast domain so that we can really be strong here and be top globally in that way. I hope I answered your question.
Can you talk a little bit about what do you have to do to train radiologists and using your software and incorporating into their workflow?
Today, the system that we set up is such that we want to do minimum change to radiologists. The competition is with adoption today. The radiologists love us, they also hate us. We improve their efficiency by 20 to 50% today. But down the road, with the many hooks I'm talking about, I'm improving efficiency by 300 to 400 times. Okay? Now, but today they see us as a threat because we could take over their job. Or maybe not immediately, down the road. So how do you convince somebody that can actually become a competitor to use your product? It's not my competitor I'm worried about, it's the radiologist. So minimum change to their whole workflow. The way that we do, they don't have to click an extra click. Everything is arranged the same way that they see it. They don't have to do extra work, but it makes their work easier. That is how we do it. So I think that's also a winning formula on the ground. We are not, we are research-oriented when we come to doing a study to prove our efficacy, but when we go to the market, it's very user-oriented. Exactly how the user want it. So we talk to them, we understand what we're looking at. Like for example, we're talking to some potential customers in the United States. Large hospital, some of them have 20 hospitals, 26 hospitals under them, more than 100,000 screening a year. They are telling us that today, with solution they already have, coming from the largest mammography supplier in the world, with AI provided, it's not serving what they want. So there are big players out there, but not solving the radiologist issue and concern. If we could address that, when we already have a solution to that, that is what we tend to do, and then slowly hook them into the game. And again, that's only one hook. There will be several others that we have put out that to increase our efficiency. That's where we intend to move that efficiency from 30 to 50% all the way to 300 to 400%.
Is the solution compatible with all kinds of imaging coming from different players?
This is what I hear from a radiologist in McGill University that we have a collaboration with. This lady radiologist told us that from the image, I cannot tell whether you are Caucasian, you are Chinese, you are Indian, but I can tell whether you have a dense breast or you have fatty breast. So it's going to be very equalized around the world. So it works well in every country. Plus, we make our solutions such that we follow international protocol on breast imaging. With their full-field digital mammography images, I'll be able to, I'm actually hardware agnostic. Whether you are using a Hologic, a Philips, or a Siemens, no difference to me. If you're coming from a PACS machine from GE or Philips, makes no difference to me. Everything works. So we intentionally set it up that way so that we're not beholden to any one player, but we can go on any platform.
Unfortunately, it's time's up. Thank you very much. So there is a first speaker. Please give a round of applause. So let's welcome the second speaker from UK, SidLife AI. Welcome on stage.
Hello. My name is Lorena Puica, and I am the founder CEO at SidLife. 10 years ago, I was given 3 years to live. 5 degrees in math, finance, and economics, and a career in investment banking, managing $250 billion on predictive analytics portfolios, and my health collapsed. That diagnosis set me on a mission to rethink the future of prevention for everyone. Today, the global burden of preventable conditions is over $10 trillion. In Japan alone, it's over $500 billion. Without prediction, we can't do prevention. And we know that 90% of these costs are preventable. That is why I've built a team of experts in AI, technology, research, to rethink the framework of what does it mean to do prevention. Our board of directors is led by Larry Fagan, head of bioinformatics at Stanford, and Jill Nielsen, managing director of Sequoia Global, a global platform of employee solutions and benefits in 143 countries. And our team of experts have expertise of over 100 years in the space of AI research and technology. The platform we have built is a proprietary large language model that focuses purely in life quality and prevention. We leverage 1.2 million research studies and 8.3 billion person years of data. That is a 70 billion parameter model, all developed in-house. This research has enabled us to really rethink what it means to have high life quality. Most models out there are very unidimensional and siloed. We've redesigned what it means to improve life quality for an individual across 9 life quality dimensions. This framework has been now recognized as the gold standard for measuring and improving life quality across the US, UK, Europe, Middle East, and soon to be Asia. The product itself is an AI companion for every person, which is powered by a digital twin that has over 753 KPIs. The data for this digital twin comes from wearables, devices, location, weather, temperature, as well as from facial biometrics, voice biometrics, pictures of food and nutrition. Our system is not only ingesting that data, but translating that data through the lens of 1.2 million research papers to provide daily guidance, support, coaching, mentoring, personalized CBT for every person in a personalized manner. On the other side, the population insights is aggregating and anonymizing this population data to better understand what are the potential savings and return on investment on this population relative to the predicted risks based on 42 risk prediction models that we have built across the 4 NCDs: stress, anxiety, depression, obesity, diabetes, cardiovascular, and musculoskeletal. And now we are building cancer. The business model is very clean and simple, B2B SaaS, and we've tripled our revenue in the last 3 years. We have also signed clients in 5-year contracts totaling $360 million in the next 5 years. Our global impact in businesses focuses on return on investment, increasing productivity, and increasing retention. For individuals, we serve over 250,000 members in 26 countries. We've improved their life quality. We've decreased their stress, anxiety, and depression by almost 50%. And 96% of members say that SID has improved their life quality. And these are our academic partners over the last almost 1 decade. We've also clinically validated the solution in the NHS, with the result being a 5 times higher impact in a 3 months RCT than seeing a therapist. We've supported students at Zurich University with their health, brain power, and self-fulfillment, as well as 35,000 students in India that have very significant challenges with their mental health, providing to them 2.5 sessions per day digitally, no people involved, purely AI, improving their emotional health and with a very high adherence rate. We are also in collaboration with Harvard in the Human Flourishing Project. We've also launched in Shibuya a month ago with very significant impacts in only 4 weeks. And based on that, they are now launching with their employees and broader community. We've also launched with Koshida Tech in Japan at the end of last year, and based on that, we've built a successful strategic partnership across Japan. Our mission is really to improve life quality for a minimum of 7 million people, deliver savings of $11 billion, and deliver a 9% reduction in NCDs, non-communicable conditions, in the next 5 years. Thank you very much.
Thank you very much. So now let's move on to the Q&A session. Please go ahead.
Lorena, very impressive. If I was going to pick who had created the best fake company, it would probably be you, because this sounds like science fiction, right? That people are going to take care of their life and reduce their stress, and with an AI twin, it's all fantastic. We've seen a very few companies succeed in sort of selling to the very, very well. You have some pretty impressive numbers you have in your forecast there for how much revenue you're going to do. So who's going to pay for this? Because we had a long conversation about this yesterday, in which we basically know it's very hard to see people caring about this, and it's very hard to motivate sick people. So who is the customer, and how are you going to get to the volume numbers you're talking about?
The business model is B2B. We've already sold this to the NHS in the UK, and this is not for the worried well. This is everyone that has a risk of stress, anxiety, depression, obesity, diabetes, cardiovascular, or musculoskeletal, which is basically about 70%
That's everyone,
of the
right?
population. Yeah, so the worried well is a slightly different category. The people that pay is organizations. If you look at the cost on corporations of non-communicable conditions that is starting to impact their bottom line, corporations are the ones that pay for this. And if the slides come back up, you can see the logos of the companies that we have launched with in these countries. Insurers paid for this. And in Japan, and actually around the world, they've paid a lot more on solutions like this than $10 what they would be paying for SID. And they've had no results. Very few of these solutions are ever clinically validated. We've done the study that we've done, the independent study done in the NHS is now due for publication in Lancet. So I am not here to tell you that everyone will pay everything, but it's fact that these conditions are costing companies, insurers, and governments a lot of money. And we are now about to launch with the UAE government for their population. The government's incentive to pay $10 to receive a $100 reduction in the person's risk of developing cardiovascular or delaying that even by 2 months is saving them a lot more than the $10 they've put in.
I get that the increase in the quality of life leads to the reduction in healthcare cost overall. That's a sound theory, and in practice, you're delivering it. My question is, okay, in the current medical system, what does your product replace or complement? The psychs, the neuros, who are the current, in our medical system as we stand, is your product going to replace or complement?
Currently, if you think of just the stress, anxiety, depression side, there isn't enough therapists in any country on the planet to serve the growing need of people that are developing stress, anxiety, depression. So there is both as a complement, but also in areas, in remote areas and in places around the world that there is no access whatsoever. I mean, think of India. We've launched in India, in the northern part of India. They all have a phone, but almost none of them have any modicum of health literacy to understand even the basics of what they need to do. It's really powerful to give them a 24/7 companion, and they speak, they type, they speak freely because they don't feel judged. That's really powerful. So we both complement therapists in areas that there are enough therapists, and where there are no therapists, we are the minimum solution in that space.
So next one will be the last question. Thank you.
Yeah, so congratulations on the presentation. Sounds like an interesting, very interesting solution. One of the quick questions I have is that related to the final user, right? Adoption for a little bit more long term.
Yes.
Because we know it's interesting and it's fun to interact with for the first 3 months. How you, what's your strategy to ensure that they will keep using the tool to actually get to the long-term results? That is your ultimate goal.
So for the cohort we have now, we have 51% DAUs, and we have 60% MAUs. That is at 12 months. We are 2 years commercially available. So that is the data across these 250,000 people in 26 countries. What we've done in different focus groups, we've identified that in most of these health apps, because it's one single pillar, people get bored. There's only so much of sleep advice that people can take on board. But if you advise them on their career, on their financial, on their social, on their environment, on their emotional health, depending on what their needs are, they are much more likely to come back. And we see people that use it 2, 3, 4 months, then 2, 3 weeks not, and then come back, and they are power users. So it's a different mentality of the product being more 360, covering different needs that people have and they evolve through time.
So time is up. Thank you very much for the speakers. That was the SID Life AI UK. And coming up next, please welcome from Singapore, TIM Healthcare PTE Limited. Go ahead.
Hi, konnichiwa, good afternoon, judges and everyone. My name is KL Cheng, CEO of the Team Healthcare. Hang on. Our company has actually developed an AI platform to rapidly triage chest pain patients safely and accurately. So let me share with you what is this solution. It's a software as a medical device. It's agnostic to any ECG machine, so we can hook up with any ECG machine to do this. So chest pain, let me tell you also what is the problem, global problem of chest pain. 346 million annual visits a year. This is a PwC report given to us that in 2025, this is the number you're looking at. And 75 to 90% of these are low risk. And yet they have to spend up to 12 to 36 hours in the hospitals. Why? Because patient safety is important. And therefore, there's an annual cost of about $10 billion just in US alone, avoidable healthcare costs, all right? So AI Trust is designed to do this, all right? To basically allow physicians to have a tool to let you know who can be safely discharged and who needs treatment immediately. So this is just a 5-minute input with ECG, vitals, age, risk factor, history, and convert the ECG into HRV with our machine learning, and convert it to output, which is a 30 days MACE outcome, categorizing into low, medium, and high risk within 10 minutes. Remember, compared to 12 to 36 hours, this is 10 minutes. And this is just a patient report, very simple. You look at the patient data, low risk, high risk. That is also a score where it's 0 to 100. And you have a 5 minutes ECG segments interpreted, as well as the graph for the doctors to look at. Importantly, we have done a randomized control trial in Singapore General Hospital, one of the major hospitals in Singapore. If you look at the metrics, without troponin, as you know, we are not suggesting no troponin, but without troponin, we can do an AUC of 0.82, all right? And a high sensitivity of 0.95, and an NPV of 0.99, all right? Next, Braille score, 0.094, which is actually means to say it's well calibrated, and therefore physician can trust this. So our business model is basically monthly subscription because it's a software. So we have 2 versions, standalone, and then we have the EMR integrated. So the standalone is 200 because we are looking at moving into clinic as well, not just the emergency department, but we are moving into the clinics. So we stop the buck at the clinic rather than having everyone push to the emergency department. So this is the traction we have across Asia. In particular, I'd like to highlight Malaysia because we're doing quite a lot of work there because Malaysia is a big country. And therefore, this adoption rate is faster, and also they find need for such product. So 4 clinics plus 1 adoption in the home-based triage, but with remote physician support. And we have already done clinical trial in Thailand, Malaysia, Philippines, as well as Singapore. And we have also have a grant proof by the Malaysian government to do a trial in the ambulance. When they call ambulance for chest pain, they triage at the home first and then know where to send to. And we're also doing another proof of value study with the University Malaya Medical Center, all right, with a satellite clinic of 104. And Vietnam borders, and then also in US, UK, we are talking to them on the proof of value study. We have a small team consisting of business leaders, clinicians, as well as tech experts. We are looking for forward stakeholders to work with us, whether it's Japan or globally, to make AI triage ubiquitous and with positive ROI for the patients, physician as well as the payer. Thank you very much. Good.
Thank you very much for your presentation. Now it's time for the Q&A session. So please go ahead.
Can you help me? So are you getting the combination of the EKG machine and the AI to places where it doesn't exist now? Or is this going to improve the throughput for current cardiologists or emergency room doctors who are reading this?
Right.
What are you democratizing this, or are you improving the speed of efficiency of where are you going with
Thank you
of
for
the
the
current
question.
things?
All the data is available now. There's no additional data required except the ECG. And one more point, we just do a 5-minute ECG rather than just a 10-second, which is generally what is done in the hospital, because we need the HRV data. So nothing, that means the protocol, there's no changes. It's an adjunct to it rather than replacing. So physicians become more confident rather than now. A lot of physicians actually discharge patients, even in the emergency department, and collapse within a day or within a week. This is happening. There's a lot of data to support that. So this is actually more accurate. So no additional data, whatever data they collect is already
But
there.
you're improving the efficiency and the quality of the
Yeah.
current system rather than putting it in places where it doesn't exist now.
The question is, of course, we also now, instead of moving just targeting the emergency department, we are moving into the clinic as well. Because you stop the buck there, then the healthcare costs will go down for the general, for the nations who are like Japan. You have a lot of older folks. They are living outside the city. To go to the hospital will take them time. And by the time they reach the hospital, you know what can happen, right? Yeah.
Can you just clarify a point of differentiation? Because there are already products out in the market, point-of-care testing products that would also be able to come to a decision diagnosis within 10 to 20 minutes, which is similar time frame to what you've just pitched. Different POCT products that would load troponin or NT-pro, BNP, etc. So where is it that you would clearly differentiate?
I like your question, because this is what everybody has confused it with. You see, there's a lot of machine or even what I call software out there to diagnose, but we are looking at safety. Because the problem is the time spent in the emergency department, because they worry about the safety. That's why even the low risk, they spend a lot of time there. So we are not looking at identifying high risk, but rather we are identifying low risk for safe discharge. For that, very little or no competition. The only competition is the risk score, traditional risk score that you get. TIMI, HEART, EDEX, GRACE. But when it comes to those that you mentioned, they are plentiful around, but we are not in that space, right? There are TriCox, there's Wuno from Korea, but they are all identifying the positive. We are identifying the negative, the low risk for safe discharge. That is what we are doing. Okay.
Have you been able to document sort of either decreased number of hours of being held in observation or number of cases discharged? What are the metrics that you're tracking that demonstrate that this works and that you can discharge the low-risk patients quickly?
Yeah. So in the question, like, I want to bring out a study that I didn't show here. Is that Singapore General Hospital, where they did a randomized control trial, they found that those using our system, that means blinded, the two arms. One is the control arm where they're blinded to the risk score here, and the other arm, which is actually with the risk score given to them. Those with the using AI triage able to discharge more low-risk patients than the one blinded without AI triage. So they actually admit more patients. That means the low risk also they admit more. So it's about 20% more. So that is the so-called additional productivity or healthcare cost reduction that we can do.
So last will be the quick question, maybe. Okay, that's all the Q&A session.
Thank
okay,
you so
thank you
much.
very much
Bye.
for the TIIM Healthcare PTE Limited Singapore. Thank you so much. And coming up next, we have from Switzerland. Please welcome with a big round of applause, Neurosoft Bioelectronics. Welcome on stage.
Hi, hello everyone. Thank you very much for having me here. It's an absolute pleasure and an honor to be able to present here the work we are doing at Neurosoft Bioelectronic, where we are building the most scalable brain-computer interface. And I will explain you what it is. But the first question you may have is, why are we doing this? Why do we want to interface with the brain? Well, first thing is that 3 billion people worldwide suffer from a variety of neurological or mental illness disorder. It can be severe tinnitus, which is this ringing in the ear, or epilepsy. And as of now, for most of these diseases, there are absolutely no treatment, and this is a growing concern in our aging population. On top of that, the brain is an amazing organ. It goes 12 times faster than we are typing on our computers, and 4 times faster than actually us speaking. So having a direct interface even for people that are not afflicted by diseases or mental illness is a great opportunity. However, non-invasive solutions are inherently flawed. So the brain signals are very, very weak, and 90% of it is actually absorbed by the skull. So having an external non-invasive solution is really, really difficult. On top of that, penetrating BCIs are invasive and not scalable. What I mean by not scalable is that they are recording from a very, very tiny surface of the brain. And they are usually rejected by the body. It's something that happened with Neuralink, if you know the company in the US. They implanted their electrodes, and a couple of weeks later, they were not functioning anymore. And the main reason is that the body is rejecting these electrodes. We are solving this issue by building a new type of electrode that are 1,000 times softer, 3 times thinner, and have a higher density of electrodes than anything that is actually available on the market. This allows us to reduce the foreign body reaction, so the body that wants to expose the electrode out of it. And since a video is worth 1,000 words, here is a little bit what it looks like. So as you can see, the electrodes are very, very stretchable, and this stretchability is basically the same consistency or Young modulus as the brain, so we don't have any mechanical mismatch between the brain and the electrode, which allows us to be extremely compliant and also access the brain. And this is one of the main points that we are doing, is that we can not only access the surface of the brain, but we can also go into the ridges of the brain and access all the parts of the cortical space to treat all the neurological diseases that I mentioned earlier. On top of that, we are able to, instead of opening wide the brain to access it, we can just drill a small burr hole, and thanks to the elasticity of these electrodes, we can deploy them on the surface of the brain, covering a large surface instead of covering very, very small surface, and we can access the full brain area. This technology has been presented in multiple peer-reviewed articles. We tested it in many, many animals models, as you can see. But also, we now have a manufacturing line that allows us to manufacture implant under ISO 13485 quality management system. And these new electrodes actually have been able to be tested in humans. So we have done our first in humans patients with these electrodes, 5 in the US, 4 in Europe for now. And it allowed us to demonstrate exactly what I was talking about earlier, that we have a better recording capability thanks to the conformability of the electrode on the surface of the brain. And we have also a better brain coverage. Now, the market that we are targeting in our business model is in multi-layered, because as you can imagine, developing a full BCI is a huge endeavor, very, very costly. So we focused in multi-layers. So the first is the use of this electrode for intraoperative use, so very short term. It's easier to get into the market, and this can be used to treat brain tumor resection and also epilepsy. Then the next step is to make these electrodes chronic, develop the computer that goes with them, and this can allow us to treat severe tinnitus as well as building motor BCI. And the final step of this is to gather all the data that we have while treating these diseases, to train AI algorithm to then, instead of having something invasive, being able to do the same with non-invasive data. So as I said, signal is coming out of the brain through the skull. very little, and the idea is to reconstruct the full signal using AI trained on the clean data that we have gathered on the surface of the brain. It's a very exciting time for us because we are now in the middle of raising 15 million Series A, and this will allow us to reach the next key milestone for our technology, which is reaching the US market, collecting more brain data for our AI models, as well as doing the pilot study for the severe tinnitus application. With that, I would like to thank you very much for your time and for the opportunity to present here, and I'll be happy to answer your questions.
Thank you very much for your presentation. So it's time for the Q&A session, please.
So the founding IP looks like goes back to the science paper in 2015.
Yeah.
This is
With Minef.
kind of a known issue, right, to design. I mean, it's the core issue, right? How do you design a good interface?
Yeah.
Why have others not come up with a solution that's better than yours? What's the insight that gives you the right edge?
Yeah, so it's a very good question. So as you said, there is a paper that was published in 2015 already, which is, when you think about it, 10 years ago, and nothing came up with that. So it's not totally true. There are other technologies that appeared. The thing is that usually people are using polyimide, which is this kind of plastic sheet instead of the silicone that we're using, which is 1,000 times harder than the silicone itself. It's just that it's easier to make. You have higher resolution in photolithography, and the connection is easier to make. And I think that the thing that we bring is really this know-how of how we connect the electrode and can make high-density electrodes that are in this material that are actually complicated to develop.
So moving on from that, there are a number of companies I know one quite well, Neuroelectrics, which is trying to do therapy for epilepsy using an external sensor. Are you going down the path of being a sort of integrated company? You're going to build the interface and create the cures and the therapies on top of it, or are you going to, would you be better off building that interface and then licensing it out to anybody else who wants to do whatever they want to do in terms of change? Are you a hardware company, or you're a hardware and a software company? I guess my question.
Yeah, no, that's a very good question. So we are indeed a hardware company first, and then a software second. And we are, I think, building toward the software because the data now are underutilized. So we want to use our data after. But I think for each therapy that you do for brain, it's so complicated that you need to make a lot of development for it. And just giving you an electrode is not enough. You need also the computer that goes with it. You need to interface it, and then you need to develop the therapy that goes with it. And what we are doing is that we have, as you saw, there are a list of projects that I presented at the very beginning, is that we have very close ties with universities. And the goal for us is to provide them with guidance, some electrodes to test their therapies. And once they have the therapy, we can put that in our pipeline.
But eventually, is the money in the treatment, or is the money in the hardware? Eventually, is the money in the treatment, or is it in the hardware?
In the what?
The money, the revenue.
Yeah, the whole.
The hardware in the electrode, or in the treatment as a whole?
Oh, it's in the treatment. I cannot tell you an electrode like this for the brain. You wouldn't know what to do with it. You need a surgeon, you need a therapy, you need a full pipeline. So, of course, yeah.
In that process, is there any... Oh, sorry, very quick one. Is there any particular adverse events you've seen in your product as you go through those trials?
So for now, we didn't see any particular adverse event. Again, for the clinical trial we've done in humans, it was for less than 24 hours, so intraoperative. So here, as long as your product is sterile and biocompatible, usually you're fine, which is the case for us. Now, what we've shown in animal models, which is, I think, much more interesting, is that when we compare, there was a comparison in the 2015 publication that polyimide and silicone were very, very different. Polyimide was squishing the neural tissue. Actually, it was on the spine, whereas silicone did not. And since then, we have done that on the cortical surface, where we have seen that regular clinical grid get fibrosis all around the electrode and get rejected by the body. quite strongly, actually. And our electrode, we just have a slight biofilm on them and actually no adverse events. So we are very confident with that. Yeah.
Thank you.
Yeah.
I'm just curious, the judge from joining us online, Ms. Levy, has any question?
Yes, thank you. Wonderful presentation.
Thank you.
I had a question about the go-to-market
Yeah.
in terms of how you plan to expand from the research institutions, the universities, to distribute the product once you have, more approvals and regulatory approvals.
Yeah. So for the first device that we are developing, which is the intraoperative for epilepsy, the thing is that the reimbursement code is quite straightforward. It's already there. So it's easy to go to market. We also have a letter of intent and discussion with people in the field that already have the distribution channels online. So we can distribute our electrode like this. So it's really the payer is of course the insurance, and there are the reimbursement code, and the buyer is the hospital, and you need the distribution channels, and we have collaboration for that. And then for tinnitus, it's a bit more complicated because there are no reimbursement codes yet. So we have a whole strategy on how we can get reimbursement code from getting out-of-pocket patient. We've done analysis and questionnaire to patient, to hundreds of patients actually, if they would be willing to undergo surgery, to pay for it, and this kind of things. And then going to public insurances that their KPI is patient health, and so they would be willing to undertake this cost, and then towards private health giver that would reimburse last, I think. So, well.
So thank you very much. So once again, please give a round of applause to the speaker this time.
Thank you.
So next up, I'd like to welcome the speaker joining us online. So would you please welcome Card Medical Limited. So the floor is yours.
Thank you very much. My name is Aron Shalev. I'm speaking to you from Israel, from Tel Aviv. Unfortunately, the skies were still closed yesterday when I was supposed to fly, so thank you for accommodating this online presentation. The name of the company I'm representing is QArt Medical. QArt stands for Quantitative Art. Art, as you know, is a synonym for IVF, standing for Assisted Reproduction Technologies. Our purpose is to empower the clinician, and specifically the embryologist, to dramatically improve IVF success rate by applying advanced biophotonics and AI to the field of male fertility. Everybody knows very well that the fertility domain is highly, highly attractive. The domestic birth rate are reducing almost anywhere in the world, to a situation where it creates real social and economical problems in numerous economies. Just a bit of the statistics of this highly famous epidemic of the 21st century. 1 out of 6 couples worldwide are affected by infertility, and so far, only roughly 1% of the babies are born using IVF, but that's resulting from a few reasons, and the most of them is the very low success rates of current IVF. Now, more than 50% of the cases of IVF involve male fertility, and some say that even 2/3 of the cases involve male fertility. And statistics vary, but typically only between 15 to 25%, that's the success rate per an embryo transfer. So when you're looking at a good-looking embryo in the dish, the success of generating live birth from that embryo is roughly 20%, 1 out of 5. Our system is called Q300, and that's the only system that uses biophotonics in order to allow extensive and accurate characterization of individual sperm cell for their selection and then subsequent injection into oocytes. It involves biophotonics, AI-driven visual analysis, and numerical autofocus, which is impossible in any other method that is currently being used today. On your left, you can see very clearly how typically embryologists look at sperm cells today. They have two very big issues. One of them is that the sperm cells rotate and go in and out of focus. So it's not even a matter of the human vision. It's a matter of you cannot measure the sperm cells accurately because they change the focus. A second problem is that since they're so small and transparent, there are internal organelles which you should basically refer to their dimensions, and you cannot. Why is that? Because it's transparent. Now, the way to do that is to chemically stain the sperm cells and then make the measurements. But of course, once you do that, you cannot use the sperm cells for injection, only for analysis. On your right, you can see what our system sees when it looks at individual sperm cells. And that's completely different set of information which we are utilizing in order to extract the basic consensus criteria of WHO today. So basically, when an embryologist examines the sperm cells in our system, completely non-invasively and non-destructively, they receive kind of like a CBC, like a blood test result chart of what this specific sperm cell look like relative to consensus WHO criteria, whether it's with all parameters within the green region, if you will, or borderline, which we denoted as yellow, or completely in the red region. Now, we do not force their hands in order to select a good or a medium or a bad sperm cell. We just inform them so that the sperm selection process is well informed. So far, we've seen in our clinical studies that using our system, you have 10 times more specificity in selecting good sperm cells. In a recently published study, we've seen 2 times higher cumulative pregnancy rates, and all of our cycles had good quality embryos that you can transfer, which doesn't happen in regular ICSI cases. Now, you can see this is taken from a recently published article, and you can see that relative to control values, we almost double between 34 and 61. We almost double the cumulative pregnancy rates, and that's statistically significant. As our consultant from UCSF says, only sperm matters. And why is that? Because, of course, this is not really true, but with the eggs, with the oocytes, you have what you have. You have what you were able to retrieve. But with the sperm cells, you have so much selectivity that you can apply. So you really need to select better quality sperm cells in order to increase the overall success rate. We've had some additional publications, both in general media and in other popular publications. And the market drivers are there, of course. We're basically the only company that breaks the glass ceiling in selection of sperm cells for fertilization, because we are using an imaging methodology that can allow access to information about the sperm cell that is unavailable completely in any other type of regular imaging method. We have our systems distributed in Israel. We have one system in UCSF and one in Tokyo University. Both of them supposed to go into clinical studies soon. And we're now starting distribution in India with the largest clinical chain group called Indira IVF. Basically, our business model is SaaS, where we do have a small, modest one-time cost of installation, $30K, and the per cycle fee of $1,000 per case. That might differ in economies where the general pricing is somewhat lower. We anticipate to have to generate this year roughly $500,000 in sales, mostly in Israel and India, and to substantially increase that to over 135 million in 5 years from now. We already have the FDA registration, CE mark, the Israeli FDA, and of course all of the quality certifications. We have a very, very experienced team, and thank you very much. Sorry for exceeding my time.
Thank you very much for the presentation. That was from Israel, and this is a Q&A session, so please go ahead.
Alon, I have a very dumb question for you. So for IVF, some sperm is donor sperm, and presumably that comes from young, healthy, males who are selected by the donor. I don't know if this is true, but one assumes that they are in good shape. And then there are old men like me trying to have babies who probably have lower sperm counts and worse sperm. Does this improve sperm from older, less older men, or with less good sperm counts, or does this improve all sperm? And then what's the proportion of IVF that comes from donor sperm from young, healthy donors compared to regular men who have infertility problems?
Only in less than 5% of the IVF cases, donor sperm is used. And why is that? Because since there are 200 to 300 million sperm cells in an ejaculate, you could always select reasonably swimming and reasonably looking sperm cell, especially if you're selecting them in a method that is done today, which is very, very quantitative and kind of eyeballing and subjective. In our method, you should probably have a lower yield of selection if you're using high informative morphology analysis, but still you could certainly get enough good sperm cell within the field of view of an embryologist. So technically, that shouldn't make any difference. The only reason why to use donor sperm cells is in some cases, roughly 5% of the cases, that the ejaculate does not contain sperm cell. This is a condition called azoospermia. In these cases, it's used. Typically, it's not necessary even for 50 or 60-year-old guys.
How are you acquiring new customers, and how does that vary by segment? Are you thinking about differences between AMCs, academic medical centers, and private clinics? I mean, you have a single pricing strategy right now. Does that also play into how you think about pricing?
Yeah, so we're now commercially active. We just began in India and in Israel. From a cost reward consideration, we're now doing fundraising in order to raise enough money in order to start direct sales in the US. Basically, in India, we're working with the largest IVF distributor, which has access to basically all of the market, which is something like 700 clinics. Now, typically, more than one distributor serves each clinic because each of them are specializing in different types of equipment or disposables. But basically, in all economies, except perhaps the US, will go through distributors that already have the active channels and know the people on the ground, etc. In the US, we'll probably have to set up our own direct sales force together with local sales experts that are coming from the local industry, like Hamilton Thorne and Urban Scientific, etc. And of course, pricing would also be slightly different. In Japan, it would be roughly $700 because that's the government reimbursement. In the US, it could approach 1,000. In India, it would be roughly around $400. And it all differs according to the regional typical cost of the total IVF cycle. We typically try to keep it within the 5% cost of the overall IVF cycle.
So next might be the last question. Thank you.
Are you gathering all the data from the selection process to understand sort of longitudinally across a big patient population? What's working, what's not working? Are there geographical differences? Are there population differences? Or what are you learning from sort of all the data that you're collecting?
In a way, we are in an embryonic position in this regard, because we don't have yet enough data to reach any, I would say, definitive conclusions. We so far didn't see any differences between different ethnicity groups in terms of sperm cells, but we do try to have all of our labs keep the individual sperm cells with traceability to the embryos, so that in a way, 2-3 years down the road, we could be a part of writing the next chapter, if you will, in what's a good human sperm cell when you acquire it in 3D. because we generate evidently a very big data set on each of the sperm cells, and that data set could indeed be very insightful for the basic research and understanding of what are the organelles, what are the sizes in the human sperm cells, which is completely ignored today due to the clear reasons, because the data is not available.
So thank you very much. So that was Quad Medical Limited from Israel. And once again, big round of applause to the speaker. Thank you so much. And coming up next, we have Anis Health Incorporated USA. Please welcome on stage.
Hi, I'm Alice, co-founder of Anis Health. At Anis, we're building the gold standard of mental health care for Asian Americans. Let me begin with a story. Jenny became depressed in her new job, but her therapist ignored the roles her Asian values played. Ultimately, her fear of losing face drove her to the edge, and I lost my close friend Jenny to suicide. Like Jenny, millions of Asian Americans are suffering from a silent mental health crisis. Suicide is the leading cause of death for Asian American young adults, and we're the only racial group for which this is true. The problem stems from current therapy frameworks being rooted in Eurocentric values, developed with only 0.1% Asian data. Therapists receive virtually no training on unique stressors experienced by Asian Americans, such as bicultural stress, intergenerational trauma, and discrimination. This is not only devastating socially, but costs the healthcare system $29 billion in annual inflated healthcare costs. We're addressing a $16 billion market with strong tailwinds. Asians are the fastest growing immigrant group in the US, with a population reaching 36 million by 2040, earning above average income. With the growing mental health needs in this population, we're unlocking a market that other one-size-fits-all platforms have a hard time reaching. So enter Anis Health, a telehealth platform offering culturally responsive mental health care driven by 3 key values. First is our provider training focused on cultural stressors and related evidence-based interventions. Second is our unique care model that we've designed for the Asian population that integrates therapy, behavioral coaching, and digital assessments and tools. And finally, our AI-powered platform scales personalization as well as streamlines provider workflow. And we're so proud of our industry-leading metrics that validates our unique approach. Across 7,000 encounters, we're seeing that 43% of our users are first-time therapy users, which shows our ability to engage a historically underserved group. Furthermore, 85% are continuing onto their month 3 of care, which far exceeds the current benchmark of 50% of Asians dropping out after just the first session. And most importantly, we're proud of our ability to deliver outcomes, with 93% improving by week 12 of care, which again outperforms benchmark. With this data, we've unlocked payer access, which is our go-to-market strategy. In 3 years, we've contracted with 11 payers that represent 5 million Asian lives covered and $1.9 billion in revenue potential. And these are more than standard in-network contracts. We've negotiated enhanced rates, including a bundled rate contract with Optum that drives a strong unit margins of about 50%. We employ a B2B2C business model where we're reimbursed by payers and we reach our patients through B2C marketing channels, as well as referrals from payers, employers, and providers. And this mix drives a strong LTV to CAC ratio of 6:1, which we expect to improve as we deepen our referral partnerships with payers. We deliver mental health care in a targeted and tailored way that go above and beyond what other one-size-fits-all mental health platforms do. Our competitive moat include our payer contracts backed by our industry-leading metrics, our rich data set of Asian American mental health treatments, which fuels our personalization, and a trusted brand within the Asian community that we've established, leveraging our first-to-market position. My co-founder Nisha Desai and I met at Harvard Business School after working in healthcare for 15 years combined. Our team has shaped behavioral health products at the likes of Humana, Valera Health, and TruePill, and our CTO is a 3-time founder with 2 companies that went public. Personally, I've lived in Japan and China, and our whole team is passionate about solving the mental health crisis for the global Asian population. We're scaling quickly and are projecting to reach 100 million ARR in 5 years by onboarding 23,000 patients that can serve with under 500 therapists, thanks to our integrated care model that expands the capacity of our providers. In the long term, our next milestone includes expanding into medication management as well as Medicaid. And in the long term, our vision is to become the leading mental health platform for the global Asian population. And I'm excited to have started some conversations with the Japanese companies here. And that's it. Thank you for listening. To follow our journey, you can find us on Instagram or LinkedIn, searching Anise Health, and happy to take questions. But before that, I also want to express my heartfelt thanks to Mehdi and Jetro for welcoming us to this amazing event. Thank you.
Thank you very much for your presentation. So it's time for the Q&A session. Please go ahead.
Thanks. I know you're dealing with one of the biggest issues for healthcare, and I applaud that. It also seems to be a heavily competitive market too, almost like a red ocean. So on the long run, how do you plan to stay competitive and to stay ahead of the game?
Yeah, so in the US, fortunately, mental health stigma has really lessened thanks to a lot of advocacy efforts, and now being in therapy is almost like a cool thing to do. It's a brunch topic that people talk about breaking up with their therapist. So demand has spiked, and there's been a lot of mental health companies that evolve. But I see a lot of the companies out there as being mental health innovation 1.0. They're a marketplace that aggregates fragmented supply and makes it easy for people to connect to therapists, but there's a lacking expertise in these provider groups that to deliver outcomes for certain populations, such as Asian Americans. And like I mentioned in my slide, I think that our long-term moat, it really lives in our data as well as our brand. So we are collecting much more extensive data on Asian American mental health, including what's bringing them into care, what types of culturally adapted interventions that our providers are offering. And we have a unique care model that integrates therapy and coaching, where you're not triaged either to a therapy or coach. Our therapist and coach work as a collaborative team to drive outcomes. So all of these data is really valuable for a lot of stakeholders out there, including payers, on how to engage this population and drive outcomes. So the data definitely for better personalization in the future, as well as our brand.
Yeah, Alice, great presentation. The challenge in mental health is the customer acquisition cost, right?
Yeah.
Anybody who's in America hears endless commercials. Every podcast, every radio, every NPR station has commercials, mostly from BetterHelp, but then previously from Cerebral and others, who have spent hundreds of millions of dollars on that advertising. And many other mental health companies, but also other disease management companies, get lost within the insurance companies' directories, and it's very hard to sort of scramble to the top. So say a bit more about your customer acquisition cost and your B2C customer acquisition strategy, because you've done the hard part of getting the insurance companies on board, but how do you get to the 36 million Asians to tell them there is this culturally explicit experience for them, the kind of way that Asian Americans go to the different supermarkets than white people go to?
Yeah. So you asked about our CAC. It ranges from $100 to $300. We are experimenting with different B2C channels, so some months are higher than others. But our focus really is where we can drive more efficient customer acquisition. So even in B2C marketing, to your point, there's tons of companies investing millions of dollars in ad spend every month on keywords like mental health, but we're able to work around that and target really specific keywords like people searching for Korean therapists in LA to bring down those costs. And the other thing about our platform is we are seeing already a really strong word of mouth referral, where about 60% are coming through B2C channels, but 40% are coming through referrals of some sort, friends and family, providers, Employers were doing a lot of community outreach effort since there is a lack of awareness within this population. So people find out about us through their ERGs that bring us in for a mental health webinar. And eventually when they're looking for care, they get referred to Anis. So we're planning to leverage a combination of B2C marketing to get in front of people who are readily seeking for this kind of care and continue to strengthen that referral channel.
Thank you very much. That's all for this session. Thank you so much. Once again, big round of applause to the speakers.
Thank you.
Thank you. Up next, we have Iris from Japan. Please welcome on stage.
Hi, we're Alice. We provide machine vision AI for diagnosing infectious diseases. Having raised $100 million, we're now getting ready for our second pipeline release and global expansion. I'm a medical doctor and used to work in the emergency room. I was a doctor riding helicopters to rescue and save people's lives. These are photos when I was working on a remote island and on a ship. I was a doctor on Hateruma and the Ogasawara Islands. There are patients in their most severe conditions in local places, and this is why we founded ALIS. We want to lessen the discrepancy of the medical services provided. We, ALIS, have developed the world's first AI for diagnosing infectious diseases utilizing throat images. Approved by the Japanese FDA and reimbursed by insurance payers, we have already diagnosed 100,000 patients in Japan. So this is the conventional nasal swab test. As you may all know, it's just so painful, right? And this is our AI throat camera. By capturing detailed images of the throat, the AI analyzes the inflammation patterns and gives diagnosis to multiple diseases at the same time. Compared to the traditional nasal swab test, our device is faster. It only takes 15 seconds for diagnosis. It's 4 times more affordable. It's equally as accurate with 80% of sensitivity. And of course, it's more comfortable. This AI, having passed through the clinical trials in Japan, have shown its high accuracy against the influenza and the COVID. Now, throat examinations can reveal signs to 200 to 300 different diseases. Our device is currently approved for the usage to influenza with ongoing development of COVID and strep throat detection. And additionally, our oral imaging can potentially diagnose conditions like oral cancer, allergies, arteriosclerosis, and many other diseases. So, good news to all of you who are here today. It's time for us to say goodbye to nasal swabs. We are now in our second year of commercial sales, and we already have 2,000 institutional users who are hospitals and clinics. We sell each camera for $1,500 US, and each generates a revenue of $7 per diagnosis. We have sold $5 million so far and are expecting another $40 million in 2 years. In order to develop this AI, we've gathered a comprehensive throat database with diagnostic results labeled through clinical research. The AI developed utilizing the database was approved by the Japanese FDA and was the first AI in Japan to be reimbursed by the Japanese National Health Service. Having successfully completed our first 2 years of commercial sales, we're now getting ready for global expansion. Our flu AI is already widely used across Japan, and we're gearing up for approvals for COVID and strep throat detection. I started my career as a medical doctor. our CTO, with 20 years of experience in business and technology field, has built the strongest AI team in Japan in machine vision and disease detection. And additionally, we're supported by strong business talent from Bain and BCG. Now, even before COVID, Bill Gates was warning us 10 years ago about the global pandemic. But now we have our AI device with us, which is capable of anomaly detection, which allows us to identify images like number 3 as novel, even without prior training. This makes it a well-suited technology for detecting completely unknown emerging infectious diseases. With ALIS, we're not just saying goodbye to nasal swabs. We're ushering in a new era of patient-friendly, accurate, and prepared healthcare for the soon-coming next pandemic. Please join us in this revolution. Thank you.
Thank you very much for your presentation. That was the presentation from Alice, and now time for the Q&A session.
Hi, can I understand your value proposition again? I think you mentioned the word diagnosis. Is your product a product that would show the image to the doctor and the diagnosis still remains within the power of the physician? Or is your product actually diagnosis in place of a doctor? I ask that question because IBM's Watson was designed to do that, but it hasn't taken off because the doctor still owns the final diagnosis decision. So where is your product positioned within that value chain?
Thank you, very important question. As you have mentioned, the doctor holds the final decision. And this is an alternative of the nasal swab test. So the doctor will use this AI, but he doesn't necessarily have to follow the diagnosis of AI. It's to the doctor's choice under the Japanese and the American law.
Thank you. So maybe a follow-up on that. How does it fit on the workflow, though?
Thank you. This device could be used also by nurses. So even before the patient enters the doctor's consultation room, he or she can be taking the photo of the pharynx. And then the doctors could see the pharynx or maybe use the AI even before or within the process of consultation.
So let me ask you, flu and even increasingly now COVID are not really diagnosed very often, right? So I have flu, I stay home. I have COVID, maybe I take a COVID test, maybe I don't. They're very cheap now in most of the world. Are you replacing something that actually exists? I mean, how many people are getting nasal swabs? I mean, is there enough demand for what you're doing here? I'm actually very surprised you've done as well as you've done already. So maybe I'm wrong here, but I'm surprised there is that much demand for this amongst doctors.
Thank you. In the mid to long term, we are approaching the oral cancer region. But the point is that there are tons of examinations held in Japan regarding influenza and COVID, which could be a learning or training data source. We don't collect personalized data, but we get all the anonymized images, which could be used to retrain the AI.
Yeah, and I agree. I'm working with a company which does a similar thing with dermatology, skin, and they have millions of images, and they're figuring out what's cancer and what's not. But so this is what we call the camel's nose under the tent to get to oral cancer and all the other stuff. And sort of COVID and flu are kind of like a way in to get there, more than the end product. Is that correct?
Yes.
How good are the data sets for all the other conditions in terms of whether you want to do COVID or oral cancer or strep? Is there sufficient size and breadth of data sets out there for you to train them? And how quickly can you get the other applications to market?
Thank you. We've gathered a database of 500,000 images before the launch of our first AI. But now we have 2 million, since every day our device is being used in the market, and we are gaining more and more data. And answering your question, it would be necessary to gather somewhere around 10,000 data, positive and negative combined, to develop another AI indication.
How many devices have you actually already manufactured and are already in use? I mean, it's $5 million. It seems like $5 million of revenue so far. 100,000 patients so far?
Yes.
And so how many devices are actually already deployed and in the field?
We have sold 2,000 devices.
Another maybe quick question for the final for this session. How about the judge from online, Levy, Ms. Levy?
I just had a question around the physical device. Do you see a case in which you don't need the actual device, but your technology can be used on a phone with a flashlight or something that attaches to a phone? I know obviously it's a hard to reach area, but I'm curious about the need for hardware versus using existing technologies.
Yes, exactly. That's what we're working on right now. We cannot go through the regulatory affairs in Japan using smartphones, but maybe in other countries that will be more suitable for our technology.
Thank you very much. So that was Iris from Japan, and please give a big round of applause to the speakers. Thank you so much. So next up is the final speaker for the first half of the pitch competition. And please welcome on stage Michael Hill from India, please.
Hello everyone, myself Shashank. I'm founder of MicroHeal. So MicroHeal is a digital therapeutic company, and our mission is to improve chronic condition management and disorder management by creating a personalized medicine by leveraging high-end technology that is combining pharmaceutical therapy with the non-pharmaceutical protocols, where we leverage high-end technology like AI, ML, AR, VR, or IoMT-based device plus a digital therapy, which can be combined with a conventional drug to form a hybrid drug concept. And this need to be rigorously validated over a gold standard randomized controlled trial. So the first product which we are focusing upon is toward functional gastrointestinal disorder, where we are focused upon 5 major conditions like IBS, irritable bowel syndrome, functional dyspepsia, that is chronic indigestion, chronic constipation, diarrhea, and GERD. So if we talk about its prevalence globally, 4 out of 10 people suffers from one or the another form of a gut disorder. And in India, it's around 20%. And in Japan also, the IBS prevalence is around 12 to 14%. And the main unmet need is like FGID is also known as a disorder between our gut and brain interaction. And it's a psychosomatic in nature. And the current solution, that is either a drug or a food science, doesn't addresses your psychosomatic issue, that is a behavioral. So our gut is connected to our brain, and there is a bilateral communication between our gut and brain axis. Majorly, people focus more upon the gut through food science and managing microbiome, but another important role that brain plays is controlling the hormonal secretion. That's where we lose or we don't even have that great data set on chronic acute disorder or life experiences. So what we have done is we have clinically validated protocols which can be easily integrated into the current ecosystem of hospital or gastroenterologist. The gastroenterologist who is prescribing medication will prescribe you the software. Through the software, a team of behavior and nutritionist will be taking your assessment and try to identify your psychosomatic issue. So as per the clinical data, we have identified 20 different types of psychosomatic issues like perfectionism, OCD related to over-information, which basically impacts your the triggering factor of physiological symptoms. So we tell them what should be the do and don't and the right therapy, whether it should be REBT, CBT, or DBT, depending upon the hyper-personalization. And that's where we are creating one of its kind data also. This is our clinical trial where TAU is the drug arm, TAU plus app is drug plus DTX. In drug arm, the primary scoring system was SSS, that is severity symptom score. You can see it's minus 94, which shows that 90% of the patient got triggered back within the 12 week of time. Whatever they reported, it's either same or become worsened. But in drug plus DTX, the TAU plus app arm, you can see it's 79% improved. So that shows the efficacy, and both the arm had the same drug. So technically, we are increasing the efficacy of drug with the same level. And the quality of life is also increased. So this is an CTRI registered trial. And why now? Because pharma is shifting towards integrative care. Global player like Bayer, AstraZeneca, Novo Nordisk, all of them are tying up with one or the another form of a DTX company. And similarly in India also. And now regulatory like CDCO and FDA started recognizing SAMD and combining software with DTX, drug with DTX. So right now, DTX has been growing with a CAGR of more than 30% and 11.5 billion of TAM market. And India and Japan in Asia has been like drastically adopting the DTX. So like as a competitor, globally we have Mahana, and in India we have Daily Bloom by Dr. Reddy Labs. It's a pharma company. But again, the major differentiator is they have self-assist CBT, which is again a generalized thing. A person who is literally depressed in some family related or some different types of issue cannot be overcome through self-assist CBT. And same goes with the Daily Bloom. And another thing is our IOMT based device, which is one of its kind device. I'll talk about device first and then come back to the business model. So this device can be installed over your toilet seat, and it will track the form of stool, frequency of stool, and the color of stool. And it will predict your gut health and will also categorize your stool as per Bristol stool scale. And it's one of its kind device. We have one of the competitor, Throne Science, which has recently predicted, but they are more into wellness side. So our business model is directly tying up with hospitals and doctors, and we're doing white labeling for the pharma company through B2B2C model, acquiring patient via them. And which also create a natural retention because we are creating a behavioral data set. Usually, even you will go to best hospital, they don't have the behavioral data set, the correlation of psychological data with the chronic condition. So we have also partnered with NITO, Marengo Asia, so more than 5 to 7 hospitals. It's been around 6 months, we have commercialized ourselves. So I look after product innovation and clinical side. My co-founder Nupur look after operation and HRA. Deepak Salvi and Ravikesh Tripathi are from Nimhans, which has helped us to create the protocol. Thank you. I would love to take questions.
Thank you very much for your presentation. So now a question is open for the judge. Thank you, please.
Can you take me through the workflow? So the device you have for stool analyzing, the patient or the consumer actually purchases it out of pocket, and then how is that data transmitted to a particular clinic or hospital? Do you need another contract? Does the consumer, the patient, need to have another contract there for that analytic data to be transferred to the clinician to identify? And how is that feedback given back to the original consumer? How does that work?
So ma'am, right now, device we haven't deployed. It's under clinical trial. What we have thought of is we'll be deploying our AI over the hospital's cloud so that all the data become secure and can be stored over there. The main thing is so we have integrated not just the image, we are also integrating sound because the borderline between 2 and 3, that is chronic constipation and normal, and 5 and 6, that is diarrheal and normal, has a lot of contradiction. Even right now, gastroenterologists are considered as a gold standard for it. So we are doing against that to prove our efficacy.
So maybe a little bit on the workflow on top of it. So the patient will see the physician, will receive the device in a future state, right? And then the device will inform back to the system, and then the patient will get some information about behavior change. Is that a good summary, or help us to maybe
So basically,
take to the patient journey?
Yeah, so I'll take you back. So the patient journey is, the software will be prescribed from the doctor. So for being easiness, let's consider we haven't deployed our devices. So software will be prescribed from the doctor side. There would be a QR. QR would be taking you through app or the WhatsApp, or let's say line for the Japanese. So that, and we'll deploy our AI over there, which will also give the behavioral intervention. Our team will be connecting through that, and they will modify, and there will be a weekly session around it. And to test whether the improvisation coming is right now patient reported, right? These all skill which I have told you. So that's why we are creating this device so it can track clinically, and it will see that there is a change in a form of frequency of stool. The form of stool has been improved or not. So it will be working as a biomarker, and also we want to use it to stop the misdiagnosis between IBS and IBD. On early cases of IBD are not detected because of low inflammatory marker through fecal calprotectin test. But in this, if we have the stress data comparing with your motion, so we can predict whether you have a psychosomatic issue or not. So that's where we are collaborating with NITO. So their stress data of watch will be correlating with our device tracker, which will tell the form of stool and everything. And if we'll see that there is continuously change due to stress factor in the form of stool, which is validating that it's a psychosomatic issue. If not, because IBD is an inflammatory disease, immunological issue. So in immunological issue, stress doesn't triggers your factor. I mean, stress also causes inflammation, but doesn't triggers your symptoms. But in IBS, it does.
I have a more general question. So this is a digital therapeutic. A couple of companies already have gone out of business trying to do a digital therapeutic in the IBS area. Even Mahana, which you mentioned, is not doing that great. And it's been very hard to get, in general, digital therapeutics onto the market, get them through testing, get doctors to prescribe them, get people to pay for them. It's just been a tough road.
True.
How are you going to avoid those problems and not just be another sort of piece of roadkill on what would be a great idea and should be great for patients, but somehow hasn't found market acceptance? How are you going to get around that?
So regarding that, sir, the major thing is like we usually measures DTX are standalone DTX. We call ourselves as a hybrid drug. So there is another company, Remipi, who is doing similar in Alzheimer. So what we are saying is we will enhance the efficacy of your drug. Rather than discovering a new molecule, why not you complement your drug with our software to deliver a better care, which we have already proven. So we want to go through the distribution of pharma, which makes it easy and scalable at the same time, and also generate real-world evidence for them. And the behavioral data set will create a natural retention. So the people who suffers from IBS have sexual problem to relationship issues to multiple other, and you don't want to talk to everyone. So that creates a natural retention that you come back to the same brand or the company who already have the data and creates a better patient, physician, and pharma relation.
Thank you very much. So that was our final presentation for the first half of the pitch. Please give a big round of applause to the speaker. Thank you very much.
Thank you so much. Thank you.
So as I said just now, this is a wrap for the first half of the pitch competition. Thank you very much for your patience.